Turbo Math. Are you tired of wrestling with tough MHT-CET matrix problems? If you are in the right place. Because in today's video, I am going to solve matrix problems with using short tricks which will turbocharge your exam preparation. Let's move towards our today's short tricks. So first we have, let's assume we have a matrix A. The elements in matrix A are A, B and C, D. So first we have the normal formula. We know A inverse is equals to 1 upon determinant of A into adjoint of A. So for we have the short trick for the adjoint of A, which is nothing but interchanging the position of A and D to the D and A and just changing the signs of element B and C. So it will become D minus C and A. Let's solve one question based on our short trick. So our today's question is about previous year question which has repeated in 2016 also. So the question is the matrix A which have the elements 1, 2, 4, 3 such that Ax is equals to I. Then we have to find the value of x, not here x but the value which satisfies this equation. So let's take this equation only. We have to find the value of x. So we will shift this A to the right side. So we will take it as x is equals to A inverse dot I. So we know already that A inverse is equals to 1 upon determinant of A into adjoint of A, and we know if we multiply anything with I, the answer will be itself. So just find first the determinant of this matrix, that is 1, 2, 3, 4. We simply know the determinant formula. We will multiply this. So determinant A is equals to 1 into 3, that is 3 minus 2 4s are 8, that is 3 minus 8, that is minus 5. So we got the determinant, that is minus 1 upon 5. Now we have to write the adjoint of A. As we know the short trick, we have to just interchange the position of the elements and change the signs. So we will just interchange the position of A and D, that is 1 and 3. So 3 will be here and 1 will be here, and just change the sign of 2 and 4 as they are the elements on the position B and C. So we will just change the sign of that. So it will become like this. That's our final answer, that is the x value is this. But if we want to remove this minus sign, we will just multiply it inside. So x will be 1 upon 5 minus 3 plus 2 plus 4 and minus 1. So let's move towards our next short trick. That is nothing but if we have any matrix A and we have to multiply it with its adjoint. So A into adjoint of A, or it is either adjoint of A into A. We have the simple solution for this, that is determinant of A into In. This is In is nothing but identity matrix and n is nothing but the 2 by 2 matrix or 3 by 3 matrix. Move towards the question based on our next trick. So here we have, if A into adjoint of A is 10 0 0 10, then what is the we have to find determinant of A. This question is repeated in 2017 and 2019. So this is very simple question using our short trick. So we know A into adjoint of A is nothing but determinant of A into In, right? So we simply know this is a 2 by 2 matrix. So our In will be identity matrix will be I by 2, that is nothing 1 0 0 1. So what will be the answer? So that our answer will be this. So simply comparing. So what will be the value of determinant of A? That this will be satisfy this. This will be nothing but 10. So the value of determinant of A is nothing but 10. Move towards the next question of the same trick. So this is the question that we have given a matrix 3 by 3 matrix. We have to find A into adjoint of A. This is repeated in 2021. So we simply know the formula of A into adjoint of A is nothing but determinant of A into In. So let's first find the determinant of A. We know how to simply find. Let's take the first element and multiply these two. 4 ones are 4 and 2 2s are 4. 2 2s are 4. This will become 0. This is the middle term. So we will take minus sign. So minus 2 will be as it is. So minus 1 into 4 is nothing but minus 4. So sign of minus, and 2 ones are 2 is nothing but 2. So we will take plus 3 and then we will multiply this. Minus 1 into 2 is nothing but minus 2 minus 1. So let's solve this. This will be nothing but 0. And this is minus. Minus 4 and minus 2 is minus 6. Minus 6 into 2, that is, minus 2, that is 6 2s are 12, but minus will give plus. So it will be plus 12. Minus 2 minus 1 is nothing but minus 3. Minus 3 into plus 3, that is minus, but 3 3s are 9, that is minus 2 plus 9, which is nothing but 3. So our determinant is 3. So the identity matrix will be 3 by 3. That will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So our answer of A into adjoint of A is nothing but 3, 0, 0, 0, 3, 0 and 0, 0, 3. Let's move to our next short trick. So here we are given the matrix such that like a diagonal matrix, we have A 0 0 0 B C and 0 0 C like this. Then what will be the value if A is raised to the any power, like A to the power 2 or A to the power 3? This can be any power. So the answer will be A raised to n, B raised to n and C raised to n. The matrix diagonals will be just raised to their powers. We have to find next. If we are given same matrix and we have to find A inverse, this will be nothing but we have to get a reciprocal or just get it divided by 1. So 1 by A, 1 by B and 1 by C will be the answer. So let's move towards the next question. This is nothing but if the matrix, we are given a matrix that is A, it is also a diagonal matrix 2 minus 2 and minus 1, then we have to find here A raised to the power 4 and A inverse. The multiplication of both. This is the repeated in the 2020. So let's first find the A to the power of 4, that is nothing but A to the power of n. So we know that. So here n is nothing but 4. So let's raise that power, let's the diagonal elements to the power of 4. So it will be 2 to the power of 4. 0 will be 0, 0 will be 0. As we know, 0 to the any power is nothing but 0. So 0 minus 2 raised to 4, then again 0, 0, 0 and minus 1 again raised to the power of 4. So here we know to the power 4. What is to the power of 4? We know 2 ones are 2, 2 to the 22 is nothing but 4 and 4 to the 8 and 8 to the 16. So it will be 16, then 0, then 0, then 0. Here even though there is the sign of minus, then also the power is even number. So that minus sign will not affect it. So it will be like 16 only, 0, 0 and 1 to the power of anything is nothing but 1. So we got the answer of A4. We have to find A inverse. We also know the formula for A inverse when the matrix is like a diagonal matrix. So what is the formula? We have to just take it or the reciprocal of it. So 2 reciprocal of 2 is nothing but 1 by 2. 0, 0 as it is, 0 is as it is. What is the reciprocal of minus 2? That will be minus 1 by 2. Don't forget the sign. So 0, 0, 0 and minus 1, the reciprocal will be minus 1 upon 1, which will be nothing but minus 1. So we have to multiply both. So A to the power 4 into the A inverse will be nothing 16, 0, 0, 0, 16, 0 and 0, 0, 1 into 1 by 2, 0, 0, 0 minus 1 by 2, 0, 0, 0 minus 1. So we know that this is also a diagonal element and this is also a diagonal element. We will just multiply this into this so that this 0 will not affect even 2. So the final answer we will get is 16 by 2, that is nothing but 8. So 0 will be 0 only, 0, 0, 0. Now here 16 by minus 1 by 2, that is minus 8, 0, 0, 0 and 1 into minus 1 is nothing but minus 1. So this is our final answer. That's it. Next was the next short tricks. We have adjoint of adjoint A. We have seen now until the adjoint of A. Now we have to find adjoint of adjoint A. So formula for or the short trick for adjoint of adjoint A is nothing but determinant of A raised to n minus t multiplied by A matrix. Now we have to find the determinant of adjoint A, that is determinant of A raised to n minus 2 bracket square. Here we have, if we have a normal, then we have to multiply it by A. If we have the determinant of A, we have to just take the square instead of A. Now what if we have adjoint of A and we have to find the determinant of adjoint A? We have the short trick, that is determinant of adjoint A is nothing but determinant of A raised to n minus 1. Move towards our next question. So here we are given the matrix A such that 1, 2 and 1, 1, 1 and 1, 1, 0 and then we have to find adjoint of adjoint A. But let's see, here is the inverse sign. So we have to find inverse of adjoint A. Do we have formula for it? No, but we do have a short trick for adjoint of adjoint A. So let's find the adjoint of adjoint A. We know the adjoint of adjoint A is nothing but determinant of A raised to n minus 2 into A. So for this we have to just find determinant of A. Let's find determinant of A. So we will take the first element, that is 1, and 1 into 0 is 0 and 1 into 1 is 1. So 0 minus 1 it will be. So second element is minus 2, I will take it downside. So it will be minus 2 and 1 into 0 is nothing but 0 and 1 into 0 is 0 and 1 into 1 is 1. So it will be 0 minus 1 and last element is plus 1 into 1 into 1 is 1 and 1 into 1 is 1. So 1 minus 1 will be nothing but 0. Then also I will write it. This is nothing but minus 1 and minus 2 into minus 1 is plus 2. And 1 minus 1 is 0, so it will become 0. So we know 2 minus 1 is nothing but 1. So we will write here the determinant of A is 1 raised to n minus 2. Can you tell me what is the n here? As you can see, this is a square matrix and it has 3 elements, 3 rows and 3 columns. So it will be 3 by 3 matrix. So the value of n will be 3. So if n is 3, then what will be the n minus 2? That is 3 minus 2, that is 1. So it will be raised to 1 into 8. So 1 raised to 1, 1 to the power anything, we know it is 1 itself. So 1 into A, if you multiply 1 to anything, it will be itself. So it will be A. But what we have find here, adjoint of adjoint A, what we have to find? Adjoint of adjoint A is inverse. So what will be the answer? That will be A inverse, because we have to find inverse. So the inverse of this will be A inverse itself. Move towards next question. We have taken the same question, but we have here to find the determinant of adjoint A. So what is the determinant of adjoint A? We know it is determinant of A raised to n minus 2 to the bracket square. Here, if we have only adjoint of adjoint A, we will take multiplied by A. We won't take square. But if we have a determinant, we will take the square, not A. So let's, as we know, this is the same example. So determinant of A would be nothing but plus 1. And n minus 2 is 3 minus 2, that is 1. 1 square is also 1, so 1 will be 1. So the final answer will be 1. So the determinant of this question will be 1. So the determinant of the adjoint of adjoint A will be 1. That's it. Let's move to the next question. It will be the last question. So we are given the matrix it is a 2 by 2 matrix 1 2 3 4, and then we have to find the determinant of adjoint A. We are just saying what is the formula or the short trick for the determinant of adjoint A, that is determinant of A raised to n minus 1. So we have to remember that if it is the adjoint of adjoint A, we will take determinant of A raised to n minus 2 into A, and if we have to find the determinant of adjoint A, we will take determinant of A raised to n minus 2 bracket square instead of A. And if we have simply given determinant of adjoint A, we will take determinant of A raised to n minus 1, not 2. So let's find determinant of this. So it will be, let's find determinant of A. So formula 4 is 4 and minus as it is, and 3 to the 6. What is the 4 minus 6 is nothing but minus 2. So it will be minus 2 raised to what? So here, tell me what is the n? It is a 2 by 2 matrix. So the value of n would be 10. N would be 2. So 2 minus 1 is nothing but 1. So the determinant of adjoint A is nothing but minus 2. Mastering these matrix short tricks are essential for your MHT-CET examination. So be consistent, and remember, being consistent is the key to success.